This video explains a set of security principles that are the framework for all security programs. These are basic ideas that are not specific just to cybersecurity or IT and are used to structure how we protect our technologies. Earlier, I mentioned Salters and Schroeder's paper, The Protection of Information in Computer Systems, published in 1975. These are also known as the design principles for computer systems. To summarize, these principles are economy of mechanism, fail-safe defaults, complete mediation, open design, separation of privilege, least common mechanism, and user-friendly interface. Let's see how a few of these work. Economy of mechanism is just fancy words that means to keep things small and simple. Bigger is not necessarily better, it just means that there's more to protect. And complexity is an enemy of security. Complex systems are harder to defend because you need to understand all of the ways it works, how it can be accessed, and how it can be broken to allow unauthorized activities. To fail-safe means to anticipate how things can go wrong and to ensure when it does, things are in a safe state. This should be the default, not an exception. To do this, you need to know how something may fail and plan for that failure, which means failing smart. For an example, let's just say you have a walk-in freezer and the power goes out. Should the freezer door lock? No, because it can lock someone inside. The freezer door needs to fail open by default. Life safety is always priority number one. In computer networks, if a network firewall fails, we want the website to be shut and not let anyone in. The website needs to fail shut by default. In computer networks, we need to decide if we want our e-commerce website to be open to everyone should a network firewall fail or shut and not let anyone in. This is a business decision. Least privilege is a concept dealing with access control. It means having the minimum privileges or permissions needed to do a job. Nothing more, nothing less. Too much, and you could be blamed if there are problems. For example, I once worked for an executive who wanted his badge to access any door in any building on the company's large campus. The problem is that if, or when, he loses his badge, the person who finds it has access to all of the rooms. Plus, that executive always has an assistant to let him in any door. An example in computers is not to use an administrator, superuser, or root account unless you need it to install, modify, or manage applications. If you use an administrator account as the default, it's a lot more likely your computer may be infected with a computer virus. The last two security principles I'll talk about are choke points and defense in depth. For this example, let's use a castle analogy. So picture in your mind a castle. Think of the ways in or out. It's limited, right? There will be a main entrance that is heavily guarded. Any back entrances may be restricted and would also be guarded. This is known as a choke point. We have the same idea on our computer networks. There's a main entrance, say, to the internet, and any back doors would be very limited to only known administrators. Castles are also known for having many layers of security between the outside and the internal crown jewels. There are multiple walls or moats and other defenses in place. In computers, we also use layers of security. Think of your home network. You'll have your network switch that has a firewall, and the computer or device you use should also have multiple defenses in place, such as antivirus or endpoint protection. This is known as defense in depth, and partnered with a choke point are some of the principles of information security.